Hello, in this video we're going to talk about values and variables, the most basic building blocks of Python programs. So if you go to the class website and look at the schedule, you might want to click on the variables and values slides right here to follow along. Okay? Okay, so every powerful programming language has primitive expressions which represent simple entities. These are basic integer values, floating point values, and so on. Means of combination, which are ways that you can combine those values to yield new values, like adding two integers together, concatenating a string with another string, and so on. And means of abstraction, by which you can create names for compound elements and then manipulate those as units. So means of abstraction are things like we can group code together and into a function that has a name, and then we can think about and refer to the function as a single whole unit. Today we'll learn Python's facilities for primitive expressions and combination, and the most elementary form of abstraction, which is to create a name that refers to a value, and a name that refers to a value is called a variable. Okay, so for the rest of this video, we'll be dealing primarily, we'll be operating primarily in the REPL, all right, because that's the easiest way to do this stuff. So I'm at a command shell, and I type Python, and now I enter the REPL. All right, so the most simple kind of value is a primitive expression. If I say 1, that is the literal representation of an integer value. That means if I were typing the literal value of the integer value, the literal integer value 1 into a program in my text editor, I would type 1. And we'll see how this is pretty obvious now, but it'll make more sense when I say the string representation of a particular kind of value when we talk about data structures later on. And we see, for example, that this is a list, and the reason it's a list is because it's a bunch of values separated by commas enclosed in square braces. But for now, simple things. 1 is an int. 2.2 is a floating point value. I can make strings by enclosing a sequence of letters in quotes. And I can use single quotes, or I can use double quotes. Or I can even use triple quotes, which I'll show you those later. Okay, so really these are the 3 basic kinds of primitive types in Python. Actually 4. Another kind of basic type, which we'll cover in more detail when we do control structures, are the Boolean values true and false. All right. Now, every value in Python has a type. You'll hear people say sometimes that Python is weakly typed, but that's not true. Python is strongly typed. What strongly typed means is that Python won't let you perform operations on a value that are not defined for that particular type. So let's talk about what types mean then in terms of the operations you can perform on them. All right, so 1 is an integer. That means that addition is defined for 1. N is defined for integers and other integers. N is defined for integers and floating point values, but it's not defined for strings. And so if you try to use an operation on a type that's not defined for that type, such as addition with a string, then Python will give you an error, unsupported operand for types for the plus operation, int and string. In other words, the left operand was int, the right operand was a string. Python doesn't allow that. All right. So it's important to think about the types of your values when you're programming in Python. All right. So how do you know the type of a value? You can ask Python by invoking the type function. And if I ask for the type of 1, Python tells me int. Notice that it's lowercase int. It's important. It's important to remember the Python types the way Python expresses them, and I'll show you why in a minute. So 1 is an int. True is a bool, which is Python's name for Boolean. A Boolean type has exactly 2 possible values, true and false. And the type of a string is str. Now, it's important to use those. It's important to know these names for the types very precisely, and here's why. So let's get back to the operations and what they mean. So I can use plus with integers, and it means addition. I can use plus with strings, and it means concatenation. All right. So concatenation of a string just means you take one string and the other string and stick the second string onto the end of the first string to yield a new string. All right. So plus means addition, as you would expect for integral types and floating point types, which are floats. So if I say type 3.14, the name of that type is float, and plus means concatenation for strings. Now, say I'm trying to make a string that shows me, I'm going to use double quotes here just because, pi is 3.14. Now, I can't concatenate a string and a floating point value. So if I want to concatenate 3.14 this way, and I know this is a contrived example, then I have to convert that to a string. And the way I do that is remember that the type of a string is str. That's also the name of the type is also the name of a conversion function that converts a type, a value of one type to a value of another type. So if I said str 3.14, then it gives me a string representation of that floating point value. And now I can say pi concatenated with convert to string 3.14. Right? And that actually gives me the string. So that's why it's important that you know those types very precisely. You know what the Python name for those types are. Okay, so some other examples. Multiplication is defined for numeric types as the splat operator or star operator. 2 times 3 is 6. Now for strings, the same thing is defined, but it's defined for strings and integers. So for example, if I say yo times 3, yo splat 3, what the splat operator means for strings is repetition. And so I've repeated that string 3 times to get a new string. All right. I can't give it a floating point value. That doesn't make sense. I can't give it another string. That also doesn't make sense. All right. And that's what types mean. Types define the operations available on the values. Okay, let's talk a little bit more about strings. All right, so strings are sequences of characters. So if I say man, bear, pig. That is a sequence of, sometimes people like to call them characters. I kind of like to think of them in Python as sequences of one character strings because, and I'll show you why in a minute. Because Python doesn't have a character type. Some programming languages have a character type which is different from a string type, and a string is a sequence of characters. That's not how it works in Python, though. So let's talk about the simplest form of abstraction, which is naming values. So I have this string man, bear, pig. Let's say I want to give it a name. Al Gore gets the value, the string man, bear, pig. All right. So the equals sign, the equals symbol in Python means assignment. It doesn't mean equality test. So equality test would be 1 equals 1. That is true. 1 equals 1 doesn't make sense because for an assignment statement, you use the assignment operator, which is the single equals, and the thing on the left-hand side of the assignment statement must be a variable. All right? Sometimes called an L value in programming languages. An L value is a value that can appear on the left-hand side of an assignment statement. An R value is an expression, which is anything that yields a value. All right? Okay, so it can't assign to a literal, but we can assign to PI. And now PI is a variable because it references a value. So variables are names that reference values. Let's sort of depict that graphically. Hopefully this didn't go to sleep. Okay, it's on. Okay. So if we have a value like a variable named pi, and we assign to it the value 3.14, then we can picture that in the computer like this, that there is a name pi, and it references, I'm not going to say points to, and it references the value 3.14, not 4. I'll put that value in a box. Okay? So that's one particular kind of value. Now, strings are a little bit different. So if I say S gets the value pi, then S is now referencing, and I'm going to draw this way. There are lots of ways to do this. References the sequence of characters PIE. All right? And because it is a sequence, sequence means that there is a first element, and a second element, and a third element. And in Python, as in most computer languages, if you came from MATLAB, this will be new to you, we index starting at 0. So the first character, or the first letter in a string is at index 0, the second one's at index 1, and then the third one's at index 2. All right? Now, I can index by, all indexing operations are this. Square brackets. And if I give this to the Python interpreter, this is actually another variable which simply points to the value at S sub 0. So I pronounce this S sub 0, all right? And then S sub 1 is actually referencing the second one, all right? So anytime you have a sequence, and we'll get into this in more detail when we talk about data structures, S references the string pi. S sub 0 is like a whole nother variable that references the character at position 0 or index 0 in the string pi. All right? Okay. Now, let's go back and see how this works in the REPL. Not too far. Okay, so let's look at our friend Al Gore, who is convinced that Man Bear Pig is going to destroy the world. All right. If I say Al Gore sub 0, it gives me the M. If I say Al Gore sub 1, it gives me the A, and so on. Now, because a string is a sequence, I can ask what its length is. Now, watch this. Do you think this will work? That's the length, right? Nope, because the string index is out of range. Because we start indexing at 0, the index of the last element of a sequence is the length minus 1. So I would have to say Al Gore 9, or Al Gore, length of Al Gore, minus 1. Now, Python has kind of a neat little feature. Honestly, I don't use it that much, but it's very convenient to get the last character of a sequence or the last element of a sequence with negative indexing. So if I give a negative index in an indexing operation, and indexes are always in square brackets in Python, then it starts counting from the end. And that gives me the last character. If I say minus 2, that gives me the second to last character, and so on. All right. All right. Another cool thing with strings that make them very convenient is slicing operations. So, which are a generalization of indexing. Okay, so if I want to pull out specific sub-elements, I can say, let's say I want the man of Man Bear Pig. So Man Bear Pig is a creature that's half man, half bear, and half pig. I want the man part. So Al Gore indexing or slicing, we call this a slicing operation, from element 0 up to 3 elements. All right, that gives me, you can think of this as, give me, this is the starting index of the characters I want in the resulting string, and this is the index of the first one I don't want. Or you can think of this as 0 is the beginning of a range, and 3 is the number of elements in the range. All right, if I do that, I get man. If I index now starting at 3 and go to, let me count here. Up to 7, so 7 minus 3 is 4, so that gets me starting at 3, the next 4 elements, that gives me the bear. And if I want to go up to the end, I can say 7 up to, actually it would be up to 10, right? Because 10 minus 7 is 3, so I start at character 7, and I get 3 characters out of it. Man, bear, pig. All right, so let's look at this sort of graphically again. So in Man, bear, pig, we have Sorry. I haven't really gotten good at using this writing tablet yet. I do hope these are enhancing the lectures a little bit. Okay, so we have index. I'm going to write the indexes above this time. 1, 2, 3, 4. Okay, so I'm just going to say AG points to that string. All right, and so if I say AG 0 colon 3, that points to, that gives me a new string from 0 taking 3 characters. So 3 is the first index not taken when it's at the end. 0 is the first index taken. And then A, G, 3, see how the eraser works. Three colon 7 gives me starting at 3 and gives me 7 minus 3 is 4 characters. All right, that gives me the bear, and so on. All right, so I think you can sort of hopefully visualize how string slicing works. Now, just to finish up string slicing, there's a special syntax. So if I say Algor and I don't give a starting index, but I give an ending index, that means start at the beginning and give me 3 characters. And if I give a starting index but not an ending index, that means start at index 0 and go up to the end. Okay? All right, so let's go back to our slides just to sort of make sure we've covered everything we want to cover. We've covered values and types, what the meaning of types are. Oh yeah, Python is dynamically typed. Let's talk about assignment semantics as well. Okay, and just a quick little pointer here. The way my slides are designed, I wouldn't use slides like this for, say, a conference talk or something like that. These slides are designed for you learning the Python programming language, and you should really type this stuff into a REPL and play around with these examples that I've got in the slides. All right. Oh, I didn't talk about expression evaluation either. Okay. Let's see. So Python is dynamically typed. So if I say x gets 1, now x references 1. And just as if I said what's the type of 1, it gives me int. The type of x is also int. Now, 1 is a value and it has a type. X, the name x, because it happens to be referring to 1 at the time that I gave it as an argument to the type function, it has the type int, but the name itself, that type is not binding. So I can reassign that to, say, a string. And now x refers to that string, and the type of x is the string. All right? So types are attached to values, not to the variables. All right, variables only have types insofar as they reference values of a particular type. Let's talk a little bit about the order of evaluation of expressions. So if I say 64 minus, I don't know, 16 times 2, it gives me 32. All right. Rather than, say, 96. So we don't do the minus first, we do the multiplication first, because multiplication has higher precedence. So that's the same thing as saying, effectively what order of operations does is implicitly parenthesize an expression. All right. Now, it turns out that that order of operation also applies when those characters are used as operations for different types. So, for example, splat is defined for strings. So if I say honey plus boo times 2, I don't get honey boo, I get honey boo boo, because the splat operator happens before the plus operator. All right, so order of operations works the same. In general, you should use parentheses liberally in your expressions so that programmers reading your code don't have to think about order of operations, because sometimes it's not so obvious. All right, so we've done that. We talked about variables. So here's another thing about variables. Variables are names that refer to values, and the names that you use can be sequences of letters and numbers and underscores, and they can't start with a number. So I can say one direction equals meh, but I can't say one direction equals meh, because that's an invalid token or an invalid name. Tokens have to start with a letter. All right. Now, notice on slide 10 here, this is a list of Python keywords. A keyword is a token that has meaning in the programming language itself. That means that you can't use it for your own identifier. So if I have, say, class gets the value CS2316, Python won't allow that, and it just says invalid syntax, which is, I wish it would say something like, I wish it would say something different, but it just says invalid syntax. And so if you ever make an assignment statement in your programs, something like this, and it looks totally correct syntactically, but you're getting an invalid syntax, then take a look at the variable name you're using and see if it's actually a keyword. All right. So keywords cannot be used as identifiers. Now, I've been using functions from Python like type and print. So print foo, right? And then that prints foo. Notice that it's a function. We know it's a function because we invoke it by putting parentheses after the name. All right? And if I say print, and I don't give it anything, that just prints a blank line. I don't give it an argument, it gives me a blank line. Now, it's a function from the so-called Python standard library. In particular, Python calls the functions that are automatically imported all the time built-in functions like type and print. There's some others like sum of 1, 2, 3, the list of 1, 2, 3. I get the sum and so on. I can actually use those variable names if I wanted to. So I could say print all the news that's fit. And now print is a variable that refers to the value, all the news that's fit to print. Notice here, by the way, that I use double quotes for my strings. Now, you can normally use any kind of quote character you want, double quote, single quote, or triple quotes. I'll talk about triple quotes more when I discuss functions and document strings. But the choice of quote character affects the kinds of characters I can put as part of the string if I want to put a quote in the string itself. So because I wanted to put a single quote in the string, all I have to do is use the different kind of quote character. All right. So for example, I could say, if I said these are scare quotes, that's invalid syntax because Python thinks that I'm actually ending the string here, and then I have, just this extra text. So that's not valid Python. So normally what I would have to do the way some programming languages do this, I can use escape characters. Which says that double quote has syntactic meaning here, but I want you to just use it as the character. All right? But an easier thing to do is simply to use different kinds of quote characters for the string itself. All right? So I'm using single quotes, which means that inside the string, single quotes would have syntactic meaning, but double quotes don't. And there I get my string. All right? Okay, but back to the original point. That was a little bit of a tangent. Print, I just redefined it to mean this. Now, if I want to print something, Python gives me this error that a string object is not callable, because now the type of print is str, because print is a variable that refers to an str value, a string value, and you can't call strings. All right. What does calling mean? What does callable mean? It means type, for example, is callable. The type of type is the class type. That's weird. Let me do something else. Type of sum. Type of sum is a built-in function. All right, that's what I expected for type. Sometimes Python is inconsistent and it drives me crazy. Okay, so type is a function, sum is a function. We know it's a function because you can call it by putting quotes at the end of it. If I just say sum, then Python echoes the value of sum, which refers to a built-in function called sum. All right. And if I say print, print is now a string value, so it refers to that string value. So the point here is Python will prevent you from using language keywords as your own identifiers, variable names and function names and so on. But you can just totally reuse function names, things from the standard library, and if you do that, you're going to run into trouble because then you want to print something down the road, you won't be able to do that, and so on. Now, if you do something like this in a REPL, you can just reset by ending your REPL session, entering Python again, and now print works as it's supposed to. Now we've got print back as a built-in function. All right? Okay, so now the last thing to talk about, we've talked about type conversions already. The last thing to talk about is assignment semantics. Now this is sort of an example that people use when we first start teaching imperative programming. So if I say x gets 1, right, and then x is equal to y, sorry. So x equals 1, I'll start over. X equals 1, y gets 2, and all right, now I say x is equal to y. Now, x has the value 1, x has the value, y has the value 2, x has the value 2 because that was the last value assigned to it. All right. If I say y gets the value 3, now y has the value 3, x still has the value 2 because y, in an imperative programming language, variables can be reassigned values. All right. So this statement here just means assign to the variable x whatever value y is referencing at this moment in time. It doesn't mean that x and y are now equal. So if I change y, that doesn't change x. That doesn't connect x and y. All right. Also for strings, if I say ff gets foo, right? But I really wanted ff to be an abbreviation for Foo Fighters. So I say ff, which is now foo, plus fighters. Sorry. And I'll put the space in there. All right. Now, I get a string that is the string that ff was referring to, plus concatenated with the string space fighters. All right. Now, what's the value of ff? It's still foo. All right. Because this concatenation produced a new value. All right. So that produced a new value. If I wanted to actually update the value of ff, I would have to say ff gets the value, whatever ff currently has, plus fighters. All right. Notice that the value of an assignment statement is none because nothing is getting printed out. All right. By the way, if I say print none, then it actually prints a string representation, but the type of none is none type. And if I say what is the type of print foo, then I've invoked the print function, which prints out Foo Fighters. And the return type of print, remember I mentioned before that every function invocation has a type, but sometimes it's just none. The return type of print is none, which is of type none type. Return value is none, which is of type none type. Okay. All right, so anyway, so ff now has the value Foo Fighters, thanks to this line here. All right, so ff is now Foo Fighters. If I do ff gets ff plus Foo Fighters again, then just adds another fighters. All right, so these are the basics of variables and values, and assignment statements, types, operations, and so on. In the next video, we will talk about Python data structures, including some more operations on strings, which are data structures in their own right. And definitely, go over the slides to get more information about that.